So the height of members of a baseball team measured in inches are 59 inches, 58 inches, 60 inches, 64 inches, 66 inches, 66 inches, 68 inches, 69 inches, 71 inches, 70 inches, 72 inches, 73 inches, 54 inches, 66 inches, and 71 inches. So I'm going to take all of the data from the height of the members of the baseball team, and I'm going to create a stem and leaf plot. So whenever you're dealing with a stem and leaf plot, the leaves are always your ones place or the last digit. In this case, they're going to be our ones place. And then our stem is going to be our tens place. So I'm going to go through and I'm going to identify what are our stems going to be. They're going to be in multiples of 10, and then our leaves are going to be in multiples of 1 based off of what each stem represents. So if we look at this one has a stem of 5 and a leaf of 9. Stem of 5, leaf of 8. Stem of 6, leaf of 0, stem of 6, leaf of 4, stem of 6, leaf of 6, stem of 6, leaf of 6, stem of 6, leaf of 8, stem of 6, leaf of 9, stem of 7, leaf of 1, stem of 7, leaf of 0, stem of 7, leaf of 2, stem of 7, leaf of 3, stem of 5, leaf of 4, stem of 6, leaf of 6, stem of 7, leaf of 1. So now I need to determine what all are my stems. So I see a 5, I see a 6, I see a 7, and I see another 5. So my stems are going to be 5, 6, and 7. So this is 50 something, 60 something, 70 something. So I'm going to take all of the 50s out of my data and I'm going to line them up over here, and then I'm going to determine from least to greatest which leaves are going to go first, second, third, fourth, and so on. So I'm going to take the number 59, take the number 58, take the number 54, 60, 60, 60, 60, 60, 60, 70, 70, 70, 70, 60, 60, and 70. Okay, so I don't have any more 50s. So my stems are all 5s. So they're all going to go in the 50 category. So I'm going to ignore those for now. And now I'm going to look at my leaves. My leaves are going to go directly beside my stem. And my leaves have to go in numerical order from least to greatest. So which means the 4 is going to go first, and then the 8, and then the 9. So it's going to say 54, 58, 59. So that represents these three numbers, 54, 58, 59. Now I'm going to move on to my stem of 6, or anything that has 60 as the value, 6 tens. So which means I'm going to talk about 60, 64, 66, 66. So there's 2 of those, 68, 69, 70, 70, 70, 70, 66, and 71. So now these all have the same stem. So they're all going to go right here. Leaves have to go in order from least to greatest, and you have to include every single number. So they're going to go in order from least to greatest. So we're going to look at the 0 first. So that's going to say 60 or 60. And then I have 64, so it's going to say 64. And then I have 1, 2, 3 66s, so I'm going to put 6 3 times. 1, 2, 3. So I have 66, 66, and 66. And then my last 2 are 68 and 69. So I'm going to move this out of the way a little bit. So I'm going to say 68, 69. So there are 1, 2, 3, 4, 5, 6, 7 values that fall in the 60s. 1, 2, 3, 4, 5, 6, 7 that fall in the 60s. So I know that I'm good. So now I'm going to move on to the 70s. So any number in my data set that starts with 7 is going to go into this area with their leaves being the ones placed directly behind them. So I have 71, 70, 72, 73, and 71. So all the stems are the same. They're all a 7. So all of their leaves are going to go right here in numerical order from least to greatest. So the 0 is going to go first, so that says 70, 70. Then the 1, so that's 71. There's another 71, so I have to put 70 and another 1. Then I have 72, so I'm going to do 70 and put a 2 over here. That's 72. And then I'm going to do 73, so 73. So I'm going to put a 3 right here next to the 2. Okay, so now my goal is to make sure that I didn't forget any of the numbers in my data set. So I'm going to count the number of leaves, and the number of leaves should match the number of pieces of data that are in my data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I know that we're good, and we have all of our data right here. Once again, this is 54, 58, 59, 60, 64, 66, 66, 66, 68, 69, 70, 71, 71, 72, 73. So I'm going to make a quick key. When you see the number 7, and then you have the little line in between, and then a 3, that means that it is 73. So that line is separating the tens place from the ones place. So that's how you create a stem and leaf plot. Now we're going to use this stem and leaf plot, and we're going to determine what is the mean, what is the median, what is the mode, and what is the range. So just a really quick recap on what each one is. So your mean is your average. You're going to add them all together, and then we're going to divide by the number of leaves, which was 15. So I'm just going to do a /15 because I know that I'm going to end up dividing by 15 for the mean. Median is the number in the middle. So when you put them in order from least to greatest, you look for the number in the exact middle. Or we can just count using those numbers there. The mode is the number that appears the most. So all you have to do is look at each stem and see which one has a number of leaves that repeat themselves the most amount of times. And then your range is the difference between the largest number, which is found at the very last leaf, at the very last stem, and the smallest number, which is the very first leaf with the very first stem. So this is our smallest number, and this is our largest number. So we're actually going to do that one first. We're going to do 73 minus 54. So we're going to borrow from the 7, that turns into a 6, and this becomes a 13 because I'm regrouping that 10 with these 3 ones over here, which means that now I have 13 ones. So 13 minus 4 is 9, and 6 minus 5 is 1. So the range is 19. That means that there are 19 numbers between 54 and 73 on a number line. The mode is the number that we see the most. So we're going to look at each stem and see if there's any leaves that repeat themselves and how many times do they repeat themselves. So 5, 4, 8, 9, no repetition. 6, 0, 4, 6, 6, 6, 8, 9. So you see right here, this number repeats itself 3 times. 7, 0, 1, 1, 2, 3. So the 1 ones repeat themselves 2 times. So there are more 6s in the stem of 6 than there are 1 leaves in the stem of 7. So your mode is 66. It is the number that you see the most. The median is the number in the middle. So all you literally have to do is just mark out a small number and a large number, or I know that there's 15. So if I take 15 and I split it into 2, that gives me 7.5. So I'm going to go 7 digits this way and 7 digits this way and see where do we meet in the middle. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is your number in the middle. So our median is 66. Another way you can do that is that you can actually write out all of the numbers in order from least to greatest and then find the number in the middle. Remember, if there's 2 numbers in the middle, you have to add those 2 numbers together and divide by 2 in order to get the median. So the mean adds up all of these numbers together and then divides that sum by 15 because there are 15 numbers in the data set or 15 leaves in our stem and leaf plot. So we have 54, 58, 59, 60, 64, 66, 66, 66, 68, 69, 70, 71, 71, 72, and 73. So that's a lot of numbers to add together. So do the best that I can. I'm going to add together my 50s, and then I'm going to add together my 60s, add together my 70s, and take those three values and add those together to make my life a little bit easier. So 4 plus 8 is 12, plus 9 is 21, so I put a 1, carry a 2. So that's 15, 16, 17. So the value of those is 171. And then I do these. So I have 9 plus 8 is 17, plus 6 is 23, plus 6 is 29, plus 6 is 35, plus 4 is 39. So I'm going to put a 9, I'm going to carry a 3. I have 1, 2, 3, 4, 5, 6, 7 sixes, so 7 times 6 is 42, plus 3 more is 45. Down here I have 3, 4, 5, 6, 7, and then I have 1, 2, 3, 4, 5 sevens. 5 times 7 is 35. So I'm going to take these three numbers now and add them together. I like to put them in order from least to greatest. It makes things a little bit easier. So 9 plus 1 is 10, plus 7 is 17, carry a 1. 10, 17, 18, carry a 1. 5, 6, 7, 8, 9. So I have 987, and I'm going to divide it by 15. Okay, so 15 does not go into 9, so I'm going to put a 0 above that. 15 goes into 98 6 times, because 9 times 6 is 30, so carry a 3, and that's a 9. So I had 98, I take away 90, that leaves me with a remainder of 8, and I bring down the 7. So if 15 times 6 is 90, which is over 87, but just by a little bit, then I'm going to go down just one number. So I'm going to do 15 times 5. 15 times 5 is 75, and that leaves us with a remainder of 12. I'm going to add a decimal, and I'm going to bring down a 0. So now I have 120. So 15 times 6 is 90, so I know that it has to be greater than 6. 15 times 10 is 150, so it has to be less than 10. So I'm going to go with 8. So 8 times 5 is 40, carry a 4. 8 times 1 is 8, plus 4 is 12. So this is exactly 8. 120 minus 120 is 0. So our mean, or the average of this set of data, or this stem and leaf plot, is 65.8. Because all of the data is pretty much clustered in one little area and there's no extreme outliers, so there's not a number that's super small or a number that's super large in comparison to the others, that means that our median and our mode, our mean and our median are going to be relatively close to each other. So 65.8 is relatively close to 66, so it's safe to say that this is actually an accurate answer. So we've talked about how to make a stem and leaf plot. We have talked about how to make a key. We have talked about how to find the mean, the median, the mode, and the range. So this is how you interpret and create a stem and leaf plot.